Okay, so today we are going to discuss uh, the new topic in the chapter polynomial, that is relation between the zeros and the coefficients of the polynomial. So our today's topic is that is relationship between zeros and coefficients of a quadratic polynomial and a quadratic polynomial. Okay, now how can we find the relation between the zeros and the coefficient of the quadratic polynomial? Okay, let us consider any quadratic polynomial in variable x, that is p of x. Now we are very much aware of the fact that any general expression for the quadratic polynomial can be written as that is ax square plus bx plus c. Okay, let alpha and beta are the zeros of this quadratic polynomial. Okay, we have assumed alpha and beta are the zeros of this quadratic polynomial. Okay, then by factor theorem we can write, then by factor theorem. Okay, then by factor theorem we can write x minus alpha and x minus beta, x minus alpha and x minus beta are the factors are the factors are the factors of p of x. Okay, now how can we write? We can write p of x, we can write p of x, p of x can be written as that is k times x minus alpha into x minus beta. Okay, p of x can be written as k times x minus alpha and x minus beta. Okay, now p of x is equal to a x square plus bx plus c, that is also equals to k times x minus alpha into x minus beta. Now we can cross multiply. We will get the equation as k times x square minus alpha plus beta. Okay, alpha plus beta into x plus alpha into beta. Okay, and in the on left hand side equal to ax square plus bx plus c. Now we can compare both sides. We can compare the coefficients of x square, x and constant term. So in next we can write comparing the coefficients. Here we can write comparing the coefficients. Comparing the coefficients both sides. Okay, if we are going to compare the coefficients on both sides, if we compare the coefficient of x square both sides, we can write is value of a comes out to be k. That is our first equation. Now if we compare the coefficient of x, then value of b comes out to be k, value of b comes out to be minus k times alpha plus beta, minus k times alpha plus beta. That is second equation. And the value of c comes out to be minus k times alpha into beta. That is our third equation. Now taking together equation 1, 2 and 3, we can see that the value of a is equal to k from equation 1. So from equation 2 and 1 we can write, okay, by equation 1 and 2, by equation 1 and 2 we can write what can we write? Value of k means alpha plus beta is equals to minus b upon a. We have substitute the value of k, so alpha plus beta comes out to be minus b upon a. Similarly, next we can write by equation 1 and 3, by equation 1 and 3 what can we write? Value of alpha into beta comes out to be, value of alpha and beta comes out to be, that is alpha into beta comes out to be c divided by a. Okay, that is the value of alpha into beta. Okay, so from here we have got the two very important results. One is sum of the roots and second one is product of. Means again we can write alpha plus beta as alpha plus beta can be written as that is minus coefficient of x. Alpha plus beta can be written as that is coefficient of x all divided by coefficient of x coefficient of. Okay, that is the value of alpha plus beta. And similarly alpha into beta can be written as that is constant term in the numerator is constant term and in the denominator that is coefficient of x, that is coefficient of. So from here we have derived two very important results, again alpha plus beta and alpha into beta. Means we can say that alpha plus beta means sum of the zeros. Is alpha plus beta, that is the sum of the zeros. Okay, sum of the zeros. Okay, alpha plus beta sum of the zeros is equals to alpha plus beta, that is equals to minus b upon a, and product of the zeros. Next one is product of the zeros. Product of that is equal to alpha into beta. Is alpha into beta is equal to c divided by a. Okay, so we have derived two very important results. Now finally here we are going to write a very important note. Okay, so we come to important note. Here we can write if alpha and beta are the zeros of a quadratic polynomial p of x. Okay, means what we are writing, if alpha and beta, if alpha and beta are zeros of quadratic polynomial, are zeros of the quadratic polynomial p of x. Okay, then we can write, then polynomial is given by, then if we want to find the quadratic polynomial, then quadratic polynomial then quadratic polynomial is given by, that is p of x can be written as k times, okay, k times x square minus x into sum of the zeros, means alpha plus beta plus product of the zeros alpha into beta, that is the quadratic polynomial. Okay, here alpha plus beta denotes sum of zeros. Okay, and what about the alpha into beta, that is product of the zeros, product of zeros. Okay, now let us solve few questions based on the this relation between the zeros and the coefficient of the quadratic polynomial. Okay, so let us solve the first question. Our first question is find the zeros of the polynomial, find the zeros of the polynomial, find the zeros of the polynomial p of x is equal to x square minus 2x minus 8. Okay, minus 2x minus 8, and verify the relationship between the zeros and the coefficients, and verify the relationship between zeros and. Okay, so how can you solve this question? Let us come to the solution of this question. How can you solve this question? Okay, first of all let us write down the polynomial p of x. P of x is equal to x square minus 2x minus 8. Okay, now we can, since it is a quadratic polynomial, we can factorize it. Means p of x can be written as x square minus 4x plus 2x minus 8. Okay, now from in the first two terms and in the last two terms, we have to come in the first two terms x is common, so x minus 4, and in the last two terms we are getting 2 is the common factor, x minus 4. Now in both the terms, x minus 4 is the common factor. So p of x can be written as x minus 4 into x plus 2. Okay, now from here we can write zeros of the polynomial px. Can we find out? How can you find? By equating p of x is equals to 0, means x minus 4 into x minus 2 is equal to 0. So from here we get either x is equals to 4 or x is equals to 2. X is equal to 4 and x is equal to 2 are the zeros of the polynomial. Now we know the zeros of the polynomial. Okay, let us denote the one 0 by alpha and the next 0 by beta. So from here we can write alpha is equal to 4 and beta is equals to 2. Okay, so sum of the zeros. From here we can write sum of zeros. Sum of zeros, that is equals to alpha plus beta. Okay, and value of alpha plus beta is 4 plus 2, that is equals to 6. Then we come to the product of the zeros. Next is product of zeros, that is equal to alpha into beta, means that is also equals to 4 multiplied by 2, that is equals to 8. Now these are the sum of the zeros and product of the zeros. Now we want to verify the relation between the coefficients and the zeros. Since from the relation between the coefficients and the zeros we can write sum of the zeros. Okay. Sum of zeros is equals to minus b upon a. Okay, so from here minus b upon a, that is equals to minus of coefficient of x minus 2 divided by 1, that is equals to 2. Okay, and product of the zeros. How can you find the product of the zeros? Next is product, that is equal to c upon a. Now c, value of c is equals to minus 8. Okay, value of c is equals to minus 8 divided by 1, that is equals to minus 8. Okay, so in this manner you have solved this equation. So we have done some mistake. Here we can write that is x is equal to, the factors are, okay, it is not, it is x plus 2. So if we equate this equation is equals to 0, we get x is equals to minus 2. Here we will get the value of x is minus of 2. Okay, so alpha is equal to 4 and beta is equals to 2. Here we can write beta is equals to 2 and here also. Okay, we have done some mistake, so we can rectify it like this. Beta is equals to minus 2. Okay, and here alpha plus beta, value of beta is equal to minus 2, so 4 minus 2 comes out to be minus of 2. Okay, here we can write 4 minus 2 equals to minus of 2. And alpha into beta, now product of the zeros. Since value of the beta is equals to again minus 2, 4 into minus 2, that is equals to minus 8. Okay, now if we compare these two things, sum of the zeros by using the factorization method, 2, and product of zeros is equal to minus 8. So our relation is true. So we have verified. Okay, so we can write here relation is verified. Relation is verified.